Today we're having a chat with Marko Djukic, CEO and founder of Hentsu. Hi, Marko. How are things going?
Hi, Ursh. Good. You?
Oh, fine. Previously we were talking about the evolution of grid computing, sort of giving a whole thing a grid computing 101. So let's dig a bit deeper. So we were talking about how various financial services are relying on high performance computing, specifically, employing infrastructure grids for various things such as, valuing portfolios, calculating risks, and so on. So from your experience, what are the most sort of common scenarios where grid computing provides the advantage, so to say?
Sure. So there are some common underlying factors which help make a case for deploying something across a grid computing platform. One of them is obviously the scale. So anything which has flexible workloads running from something small, so some real small job, to running a huge workload that scales that across a massive resource, or not running at all. And that's also important, that kind of intermittency, that it might be batch operations which come into play on a once a night, once a week basis, and the rest of the time don't actually run. And again, you can distribute this across the grid when needed. There is the parallelism, which is the operations which can be run in parallel. So chunking up the commute so that it can be distributed across multiple nodes and done in kind of parallel streams. And that may not be possible in some workloads. So that is a key common factor, because the grid computing is all about trying to get as many nodes as possible to work in unison and get through the operations as quickly as possible. What this then applies to is fairly irrelevant. It could be the trading, could be the portfolio analysis, finance, back-end accounting. We've even seen it in use cases such as sales. Basically, it's anything which brings value to the business. So as long as we can take a problem that may take days, can we reduce it to hours or minutes? Or if it's hours, can we reduce it to hours and seconds to get the job done? And as long as that brings value to the business, brings some answers quicker and faster and with more quality, then it's a useful scenario for deploying it to grid computing. There is also one other element, and that's cost. And if we can take some of the underlying common factors and some challenges to how we deploy the grid computing, in most cases, that it does actually turn out to be much, much cheaper than running dedicated resources or monolithic resources, or trying to scale up vertically with the resources as opposed to horizontally scale across the clusters. Sure.
Yeah, that makes sense. So basically what you're saying is that this saves a lot of time and improves performance simultaneously, right?
Well, so it can do. And it's not necessarily about always saving time. Most cases it is, but as I kind of touched on, the cost effectiveness of it can come into play.
Sure.
One of the use cases that we've had a number of times, and also quite recently, was taking a large monolithic compute structure for portfolio analysis and breaking it up into microservices that can actually run across a grid computing engine behind the scenes, and that basically cut the cost for the entire compute to a tenth of what it was before.
Right.
And that can come into play quite often.
Sure. I mean, I guess you could say, I sort of get a feeling that there's a big challenge to all this, right? When it comes to, grid computing at scale. So essentially, when, companies decide to go towards cloud adoption, and as we said in the previous, chat, the greatest challenge is knowing what to pick, in terms of cloud providers and solutions and stuff. So From your experience, I guess, what would you say is the kind of sort of best scenario where we could help, pick things apart and get the best possible recommendation?
Sure. So there is no single answer for a start. Each approach is quite unique.
Yeah, specific. Yeah,
because what we're looking at is often where the client is coming from in terms of the current setup, where they want to get to, what kind of data they're dealing with, what kind of compute, and what kind of business value they're trying to bring to the business at the end of the day. There are some challenges, especially around migrating some of the existing workloads if we already have them on premise. Pulling that apart, looking at the legacy setup and trying to figure out how that maps to the cloud. And that becomes even more of a challenge when the mandate is to keep it hybrid. So having workloads which run on premise to then scale out into the cloud. And of course it's doable, but it's that balancing act of what are you trying to leverage? Is it just the burst out capability into the cloud? At which point your on-premise is pretty much the master. There is always that kind of challenge. Where does the data reside? What's the golden copy? Even before getting into, what functionality can we leverage between both the on-premise and the cloud? Because fundamentally they're different beasts. And, we can get into some common layers, especially around Docker and so on, but there are two different platforms. There are some approaches to that from the cloud providers to bridge it the other way around, where they're bringing their kind of outposts, as Amazon calls them, or the kind of the on-premise stacks of the cloud environments. But we've not seen that as much of a trend as just getting wholesale the workloads from on-premise to the cloud. That data residency comes into play also with multi-cloud, and some of the kind of the benefits of going with the cloud platforms is going with the serverless approaches. And that's definitely a challenge when there's legacy code involved. How do we refactor that? How do we get that into a state which is usable in this kind of serverless environment? Because often they're completely different beasts. And what may have worked really well on premise with standalone instances and servers and so on is a complete rewrite for doing serverless. But that's again, it comes down to the unique approaches for each client, and we need to look at the existing environment and what they have and how we tie it into the data where it says what compute they're going to go after and what code they're trying to run.
Right. So it's basically just trying to optimize and improve things. Like in each individual case, it's a challenge, but it's kind of achievable and doable.
Yeah.
And
I mean, there's always repeatable patterns that we apply.
Sure.
But it's always tailored to what we have as the underlying challenge.
Yeah, sort of. So, like generally in IT, it's been noted that various organizations are utilizing different analytic tools on separate clusters, and this is apparently called the cluster sprawl. And cloud computing is something of a turnkey solution there. Using various cloud-based PaaS offerings. So do you think you can talk about that a bit more?
Interesting question. So cluster sprawl, I mean, it's in some ways it is kind of helped along with this ease of spinning up resources and being able to access different cloud providers, different cloud platforms, different compute platforms, and features and functionality. And we've actually seen it with a number of clients, the ease of spinning up resources and being able to delegate a lot of this workloads to the end users that are trying to work on the data, even non-technical users in some ways. having all this power to them, they can pretty much go wild. So these turnkey solutions, they're great. They have this democratization of the technology and empowerment of the end users, but similar to kind of just the regular cloud sprawl and resources sprawl, these clusters can themselves get multiplied exponentially. With what we're trying to kind of approach it through templating, reusable patterns, and tight business guardrails around what users can do, this does help mitigate this kind of cluster sprawl. It's about governance at the end of the day. And part of it is the kind of what the end users see as the guardrails that they can do, but part of it is just giving those tools that allow easier, consistent use in terms of what the business expects to have running at the end of the day. The other key approach that we take is to have really tight configuration management. This helps mitigate a lot of that kind of awareness of where things are running. It can start from the basic of just having all your configuration as code and stored in Git. We extensively use Terraform on top of that, and that helps keep in check what the infrastructure is and how that is used and spun up and deployed across different cloud providers. At the end of the day, you do need to kind of balance it out with trying to empower the user and getting the right business value as quickly as possible. So there is a fine line to walk between too much locking down and too much freedom as well.
Yeah, but from what I'm getting, it's just like it can be a challenge to set it up, but once it's set up, things run smoothly. That's the point.
Sure,
right?
but you're always innovating. So it's,
of course,
it's the beauty of the cloud platforms that they are constantly evolving. And
that's pretty cool. That's pretty cool.
Yeah, what was used, to great effect a year ago is something now replaced with something new and fancy and shiny, and you do want to get it into users' hands quickly. So it's finding those methods to get them out to the users through such patterns and repeatable kind of templates that we have, and leveraging the configuration management tooling as well.
Sure. Yeah, that sounds pretty awesome. Actually, it's one of the more interesting aspects of cloud tech. So, talking about compute and networking, network bandwidth, and so on, let's talk a bit about on-demand elastic compute power.
Sure. The interesting trend last few years has been the serverless approach, and obviously, that's underpinned a lot by the Docker framework.
Sure.
We've seen it used both for kind of ad hoc workloads. You need something which just answers a API query once a day. It can be spun up as a ephemeral resource that just responds to a query and then disappears after that. But it also lends itself really well to the massive scale out, as mentioned just earlier. We're talking about that elasticity that the cloud is famous for, the utility computing that's often talked about, that we can take it from nothing to tens of thousands of nodes in a matter of seconds. But it obviously can't work in isolation, as considerations around networking, about data access, security. What are the kind of the intermediate layers to the other workloads that work with this elastic compute? Because you can easily solve one problem where you scale out to 10,000 nodes, but your pipe back to the office to get it to the users can't actually handle it. So there is a bit of a holistic approach to trying to kind of marry up what is the end result that we're trying to get into the user's hands. And obviously there's the growing function of the service approach as well, where you're not even thinking about the serverless approach. You're not thinking about even the kind of the Docker containers. You're just looking at the code and getting it out, and doing the compute on that. And that's something that's both growing as the cloud provided function as a service, but also this kind of hybrid approach of running your own frameworks across the Docker, the underlying workload behind it.
Right. I understand that totally. And well, from from what we've seen so far, I think that one of the main reasons why I guess these huge number of these companies, like hedge funds, financial services, are sort of shifting to grid computing, and automation is a huge thing lately, right? I mean, for like across the board. And, being able to handle, as we mentioned, single projects with like massive resources and computing power, and it's all working towards the same goal, so to speak. So can we talk a bit more about that, like any other benefits of cloud-enabled grids?
Sure. I mean, we got to start with the basic premise of what business value we're trying to bring to the business.
Of course, yeah.
Because all of that is irrelevant if we're not actually bringing something useful to the business at the end of the day. But there are elements of obviously the scaling, the throughput, the provision of resources, and again coming back to the configuration management, that becomes very clean, very tidy, very manageable. But also it does get into some of the security as well. Again, running across the cloud platforms, you get access to all these features that are constantly evolving, and there is the security element of it that's quite key, especially when dealing with some of the financial data analysis and IP that's being put through these grid clusters. The other aspect, and one that's also been coming up recently with a few engagements, is you mentioned enterprise kind of wide visibility, but it's broader than that. It's access from anywhere. So we can have the resources in London working with the same data as resources in Singapore, with very little kind of drawbacks in terms of latency and access to data and so on. Just being able to use this global platform and the scale of it, and that allows more of the kind of distributed workloads being used by distributed teams as well. They're not necessarily tied to a single location or the single kind of machines and servers, but it's utilizing that cloud compute wherever it is. Obviously, you come into those kind of challenges around data and the kind of the access to it and where it resides, but we've seen it solved quite easily, that we can enable the users to work across time zones, across regions, and use the scale out across multiple cloud locations as well as cloud platforms. And that's kind of the flexibility of having this cloud power under your fingertips. Yeah, sure.
That sounds pretty cool. So in closing, I'd like to just mention like one specific thing here, and a specific tool, namely Azure Batch. And how would you say that from our perspective here at Hentsu, how does that work in various scenarios? What are the biggest advantages?
Sure. So we've seen Microsoft pick up the pace on rolling out some of their grid computing and AI and machine learning and business intelligence tools quite rapidly. We've rolled out a number of different scenarios, both for clients and for us internally. We've built out reusable patterns around data ingestion and analysis, very specifically asset management workloads. Internally, we use it for a number of different business cases. One of them, for example, the financial services that we provide internally around accounting, around billing, and so on. All of that is based off of Azure Batch. Because at the end of the day, you talk about workloads that bring value to the business, not necessarily exactly what they are. But in terms of client scenarios, these are around data ingestion, portfolio analysis. But what we've actually seen quite encouragingly is the rapid uptake of these Azure Batch solutions, purely around the ease and the cost effectiveness of it. So what we've been able to do is stand up these environments, hand them over very rapidly to users with minimal kind of ramp up. And that's what's been quite successful, that they're wrapping up a lot of the functionality in this platform as a service, easy to use and consume type of packaging.
Cool. Well, like, you know, it almost seems because it seems that because it's constantly evolving, it's like an endless topic, and we will be, you know, having other discussions tying into both, you know, grid computing and the public cloud in general. But otherwise, thank you for your time, Marco.
Pleasure.